All right, welcome. This is the 6th video in the series on solutions. And today we're going to talk about mathematical expressions of concentration. So what you see here, you don't have to draw this in your notes. I just wanted to have this in here for reference. I put in a beaker 2 solutions. And if I asked you to describe the difference between the solutions, what would you say? Would you say that this one looks weaker? Is that the expression you would use? Or would you say less concentrated? And if we were talking about, let's say this was Kool-Aid, you would assume that this would taste stronger because it's darker, and you know that darker means more concentrated. You know, that's everything you know about solutions you learned Kool-Aid. Well, it's not enough to say more concentrated or less concentrated. We have to be able to have a mathematical way to express molarity. And we're going to talk about the two main ways, which are molarity and molality. I'm not quite sure yet if I want to do molarity just on this one video by itself, or if we'll do them both together. We'll see where we're at when we're done talking about molarity. But molarity is the moles of solute divided by the liters of solution. Or you could say your total volume. We use a capital M, and it's kind of usually in like an italics to represent molarity. So this is a capital M. So anytime you see this capital M, you know they're talking about molarity, and that's equal to moles of solute over liters of solution. Now, you will have a formula sheet on this test, but it's not a bad idea to memorize this equation, because it's, if you can know the difference between molarity and molality very quickly, that's a good thing. The other way we can write this is MOL over L. And this is the one we use most commonly. In exceptions, we're going to see that this actually proves to be better. But so the definition really isn't too tough. So what we need to do now is we're just going to work through some sample problems. All right, so I have, and again, I'm going to encourage you guys to make variable banks for these so that, you know, to help you out. What is the molarity of a 2-liter solution that is made from 14.6 grams of sodium chloride? Well, when I see molarity, I know I'm going to have moles of solute divided by liters of solution. SOLN is an abbreviation for solution. So I need molarity, I need moles, and I need liters, which is volume. All right, so my question word is, what is the molarity? So that's going to be what I'm solving for. Of a 2-liter solution, oh, there's my volume, 2 liters. But now I need moles. Give it to me in grams. And by now, you guys should be pros at doing mole mass conversions. So I have to convert this to moles. All right, I'm starting off with 14.6 grams of NaCl. And I'm going to put that over 1. To go to moles, if you don't remember, use your diagram, we're going to use molar mass. Every time we convert mass to moles, we have to use molar mass. Chlorine is 35.5, and grab my calculator here. Sodium is 23. So if I take 23 plus 35.5, I get 58.5. So I have 58.5 grams of NaCl in 1 mole of NaCl. I'm going to cancel my units. Grams is going to cancel. That's going to leave me with moles. And when I multiply and divide, whoops, oh gee, 14.6 divided by 58.5 gives me 0.25 moles of NaCl. Now I can bring that over here. So I can now plug my values in to my equation. Moles is going to go here. Liters is going to go here. So I know that my molarity is going to be 0.25 divided by 2 which gives me a 0.125 molar solution. All right, next one is a practice problem. So pause the video and take a shot at this and see how you do. Okay, so we had how many grams of HCl exist in 500 mils of a 0.5 molar solution of HCl. Okay, so I see that molarity. So I know at some point I'm going to be using molarity is moles over liter, and that's moles of solute. But they're asking for grams. Well, okay, let's work this a little bit and see what we end up with. So I'm going to have my molarity, I'm going to have my moles, and I'm going to have my volume in liters. And this has to be in liters. So my molarity is 0.5 molar. My volume is given to me in milliliters. And let's once again go back through, how do we convert? So I've got kilogram, hectogram, decagram, base, deci, centi, milli. So if I have 500, my decimal is here, and I want to go, this is in milliliters, and I want to go to liters. I'm going to go milli to centi, centi to deci, deci to liter. It's going to be 0.5. So my volume here is 0.5 liters. All right, so I'm going to have one, I can solve for moles. Now, they don't ask me for moles, though they ask me for grams. So you're going to have to do a back conversion of moles to grams. All right, let's solve for moles first. So I have 0.5 molar. It's going to be equal to moles over 0.5. And when I solve for this, I get 0.25. I get that I have 0.25 moles of HCl. Okay, problem doesn't ask me for moles, it asks me for grams. So let's do a mole to mass conversion. I'm going to take 0.25 moles over 1, and that's HCl. And I'm going to have to multiply that by the molar mass of HCl. I have 1 mole of HCl. Chlorine is 35.5, hydrogen is 1, so this is going to be 36.5. And when I solve this, I get 9.1 grams. All right, so here are my takeaways. There are 2 mathematical ways to represent concentration, molarity and molality. We talked about the first one, molarity, which is moles of our solute divided by the liters, total liters of our solution. Often what we're going to have to do is either take our moles and convert to mass, or start if we're starting with mass, convert to moles. But we can use that then to calculate the grams of solute we need if we want to make a certain concentration of a solution. And again, it's something when I was a chemist that I used almost on a daily basis. Very, very common thing. So I would be remiss if I let you leave chemistry without learning about molarity. Okay, this has been long enough. I think we'll do molality in a separate video. So molality is coming up next.